Hello, welcome to Forbest Academy. Today we're going to be solving a calculus AP BC question. The question says, for what value of k, if any, is the integral running from 0 to infinity kx e to the power of minus 2x dx equals 1? So those are the choices. So we're told that this somehow has to be equal to 1. So we need to pick a value of k to make that happen. So first of all, let's consider the integral with a finite limit. Let's say a. K is a constant, so I can pull it out of the integral. And let's just look at the integral itself. Forget about k for the moment. So how do we evaluate this? We can actually integrate this by parts. So to recap, this is how integration by part works. So in our example, let me pick u to be x. I'll let dv to be the remaining, which is minus 2x dx. Okay, so that means this turns into this, so that's u dv. So we have u and v. That will just be x multiply v. Well, v, we just integrate this, which is just minus 1/2 e to the 2x, minus 2x. And minus integral of v du. Again, v and then as you can see, du is just dx. So now put the limits of integration. Right, so this term here becomes that. Let's simplify that. Integrating this one more time. Okay, let's just keep simplifying this. So to do that, we're going to put out a factor of 1/2 e to the minus 2x. Actually, let's put out minus 1/2 e to the minus 2x. Okay, now we just need to evaluate this expression at the limits. So to do that, let's continue here. That's the upper limit. Minus the lower limit. Okay, so let's simplify this. So when you look at the lower limit, e to the power of 0 is just 1. There's a 0 here, so that term is gone. So we only have minus 1/2 multiply 1/2. There's a minus sitting outside of this, so that all of this term becomes 1/4. Now we have this part here. Now remember, we're gonna let a goes to infinity. So we evaluate the limit as a goes to infinity of that expression here. All right, let me put it better. Okay, just look at this limit. On the numerator we have something that is linear, and in the denominator we have something that is exponential. Should be a plus here. Okay, so an exponential grows much faster than a linear function. So as a goes to infinity, this goes to infinity, but this also goes to infinity, but much faster than this one. So what you end up doing, you're dividing this fraction here actually goes to 0 as this denominator just grows much faster, right? So this limit actually goes to 0. Now, one way you can prove that more rigorously is just apply L'Hopital's rule, and indeed you will get that the limit goes to 0. But this is just a much faster way, and it just saves time. Okay, so what we have shown, let me just go back here. What we have shown is that this integral here, that's what we just evaluated, is just 1/4. That's what we've done, right? Now the original problem stated that the integral is equal to 1. Okay, well the integral itself, pulling the k out since it's a constant, we can do that. So the integral is just 1/4, multiply k, and we're told that has to be 1. So the only way this works is k itself is 4. If k is 4, then of course 4 divided by 4 is 1, and that's what we want. So the answer is 4. Alright, thanks for watching. If you need more videos like this, please don't forget to subscribe to our channel.